I go to the isobaric process in the case of P constant. P constant. In this case, if we have P constant, you know omega equals to integral of P dV. If we have between initial state and final state, initial and final, if P is constant, we can put P outside, so equals to P integral of dV. And you know the integral of dV equals to V. So equals to V P times V final minus V initial. So omega equals to P delta V in the case of P constant. We can write delta E equals to delta Q minus delta omega. You know, if we have P constant, delta Q must be equal to N Cp delta T. Okay? And delta E in all the cases equals to N Cv delta T. And d omega is calculated now equals to P delta V. Okay? So, look here. We can write this equation delta Q equals to delta E plus d omega. If we increase the volume, you have to understand this point. If we increase the volume, in this case, omega must be positive. Okay? So d omega is positive. Or we can say the opposite. We can say here, if we have Qn, if we add Q, so Q is positive. You know, if we add Q, you must have a positive delta E. If Q is positive, delta E is positive. If Q is negative, delta E is negative. So if dQ is positive, delta E must be positive. If I give, for example, 400 joule of Q, will be transferred some quantity to the internal energy, for example, 250 joule of internal energy, and here we have 150 joule of work. Okay, it must be positive. If we add a quantity of heat, we have a movable piston, you increase the volume of the piston. In this case, omega must be positive. So this positive value equals to this one plus this one. So the added quantity of Q must be divided between the internal energy and the work out. Okay? If we can say dq equals to dE plus d omega. If we have Q out, I mean Q is negative. Q is negative. For example, here we have minus 400. Okay, so delta E must be negative. For example, we can get here minus 250. It's an example, okay? And in this case, we have a decreasing of volume. If you calculate the omega, I want to calculate the omega. The omega equals to minus 400 plus 250 equals to plus minus 150 joule. What I mean, we have a negative value of work. It means we have a decreasing of volume. If the omega is negative, the volume will decrease. So you have to know very well, you have to understand very well. In the case of isobaric process, what you have exactly If Q is positive, du is positive, omega is will increase. If Q is negative, so we have a negative value of delta U, and the volume will decrease. Okay, here will increase and here will decrease. Delta Q equals to NCP delta T, because we have a constant P. D omega equals to PdV, and D equals to NCV delta T. Okay, you have to know this point. Qn is positive, so NCP delta T is positive. In this case, we have a work out. The work is provided by the gas. We have an expansion. So omega n equals to omega out plus increasing of energy. Omega out, it means omega is positive. Omega by the gas is positive. And here we have the opposite case. Okay, a simple example. Initial state A, we go to the final state B. Initially, we have the state A with VA or V1, and the state B, we have V2. You know, PA equals to NRTA divided by VA, or we can say PA VA equals to NRTA, PB VB equals to NRTB. If we divide this one and this one at a constant P, we have P with a constant value of NR and R. We get finally VA divided by VB equals to TA divided by TB. Or we can say VA divided by TA equals to VB over TB. Okay? We can here also, let me write PA VA equals to NRTA. And we can say VA equals to NRTA divided by PA, and VB equals to NRTB divided by TB, PB. You know, in this case, if we increase the volume, so if you look well here, we have N is constant, R is constant, and P is constant. Okay? If VA is greater than VB, we increase the volume, so TB must be greater than TA. So VB greater than VA in this example, so TB must be greater than TA. So EB, you can say here, delta T is positive, so delta E is positive. If delta T is positive, delta E is positive. If delta E is positive, so we must have Q hat. You have to know this point. Delta E is positive, so we have Q hat. So from the point A to the point B, we have Q hat. I calculated the sign of Q by mathematical calculation, but you can understand this situation how. We come back. If we have A and B, initial state and final state, if I increase the volume in general, P must decreases, okay? must be decreased. If we increase the volume, P and T decreased. To keep a constant volume of P, we have to give heat. Okay, so you have to know in general, if we increase the volume, P decreases in general. I want to keep its value constant. In this case, I give a quantity of heat to keep PA equals to PB. This is physically, by talk. I explain the physical meaning in general. But if you want to prove that Q hat is positive, you have to write this one. VA, VB equals to NR TA divided by PA. VB equals to NR TB divided by PB. We have the constant. If VB is greater than VA, so TB is greater than TA. Delta T is positive, so delta U is positive. Delta U is positive, so Q must be positive. Like this, you prove Q is hot. I can ask you, tell me how Q can be positive or negative. You have to write the calculation. But if I speak, I don't need, and I want to understand quickly, you can say A to B, I increase the volume, P decreases. To keep its value constant, I give Q hat. Here I take the opposite direction. I go from the initial state at the point B to the point A. Okay, here we have initial state 1 to the final state 2. You know, PA equals to NR, no, we can say VA equals to NR TA divided by PA, and VB equals to NR TB divided by PB. If we have a constant value of NRPA, NRPA. You know, here we have VA is, or we can say VB is greater than VA. Okay, so TB is greater than TA. So delta V equals to V final, delta V equals to V final minus V initial equals to VA minus VB. So it's negative value, negative value. So delta T, which is equal to T final minus T initial, is also negative. If delta T is negative, so delta U must be negative. If delta U is negative, so Q must be negative. It's Q cold. So between B and A, we have Q cold. This is by mathematical proof. Physically, without calculation, you know, if I decrease the volume, so P increases. If I decrease the volume, I increase P and T. I don't want to increase P, so I release a quantity of heat. So we have Q cold. This is by talk. Okay. So here, you know, the work is the area under the curve, this one, which is equal to V2 minus V1 equals to this one times P. We can say equals to P times delta V, simply. Okay? P times delta V. Okay, what about the sign of omega? If delta V is positive, we increase the volume, omega must be positive. If we decrease the volume, delta V is negative, so omega must be negative. You have to know all these points to be sure from the answer. If you have a good answer, for example, if we have the volume increases, omega must be positive. If you have a negative value of omega, so you have a mistake. You have to